Breaking news. Earth-like planet found just 11 light-years away. Water vapor detected on a super-Earth. Strange signals from Ross 128 baffle astronomers. These aren't science fiction. They're real discoveries in our cosmic neighborhood. We're mapping our local corner of the galaxy, one star system at a time. Imagine standing outside, looking up at a sky full of stars, each one a sun. These stars aren't just distant specks. They're destinations with their own planets. Some of these worlds might even be like Earth. For humanity, this is the next great journey. We've walked on the moon, sent robots to Mars. Now we're looking beyond. Every new discovery brings us closer to understanding our place among the stars. The thrill of discovery drives us forward, just as it did for explorers centuries ago. The universe isn't static. It's full of worlds and possibilities. The night sky is a map, and we're just beginning to read it. Each star is a potential story, a new chapter in the cosmic book. Some of the first chapters are right next door, waiting for us to explore. We're not just looking at the stars anymore, we're getting to know them. Our local stellar community is more vibrant and full of promise than we imagined. The discoveries we make today will shape the journeys of tomorrow. Each headline is a reminder. The universe is alive with discovery. We're only at the beginning of this adventure. The stars above are no longer just distant mysteries. They're our neighbors. And the next great story could be just a few light years away. The sky is calling, and we're finally ready to answer. Let's turn the page and see what's next.
When you gaze at the night sky, it looks like all the stars are the same distance away, a grand illusion. In reality, the universe has depth. Some stars like Deneb are thousands of light years away. Others are much closer. Think of it like city lights. Some are distant, some are right in your neighborhood. Our sun is one of these neighborhood stars, surrounded by many others just a few light years away. A light year is about 9.5 trillion kilometers, a huge distance, but in cosmic terms, it's just down the street. Understanding these distances transforms the sky from a flat picture into a three-dimensional space. The constellations are just patterns from our perspective. Their stars are scattered at different depths. Our true neighbors are all around us, in every direction. These are the stars we can study up close, searching for signs of life beyond our solar system. That's why astronomers focus on our local stellar neighborhood. It's the only part of the galaxy we can explore in detail right now. We can detect planets by measuring the wobble of these stars or analyzing the light passing through their atmospheres. We're like cosmic detectives, piecing together clues from these nearby systems. Each clue helps us understand how planets form, what they're made of, and whether any could be another home for life. Our neighborhood is a laboratory for discovery. The more we learn, the more possibilities we uncover. The search for life starts right here, among our closest stellar friends, and every discovery brings us closer to answering the question, are we alone? Within 50 light-years of our sun, astronomers have found over 1,400 stellar systems, a crowded cosmic neighborhood. Most of these stars are red dwarfs, small, cool, and faint, making up about 75% of all stars in the Milky Way. Our closest neighbor, Proxima Centauri, is a red dwarf just over 4 light-years away, visible only with a telescope. The rest include sun-like stars, binaries, and even triple or quadruple systems. Where there are stars, there are often planets. Kepler and other missions have shown planets are common. That means thousands of worlds could be within 50 light-years of Earth. Some are gas giants, some icy, and some may be rocky like Earth. Exploring these systems is one of astronomy's greatest challenges. With new telescopes like James Webb, we're peering into the atmospheres of these nearby planets. The answer to, are we alone, might be waiting in one of these nearby systems. Let's visit Ross 128, just 11 light-years away in Virgo, a red dwarf, much smaller and cooler than our sun. In 2017, astronomers discovered Ross 128b, a planet very similar in size to Earth. It's a rocky world, about 1.4 times Earth's mass, orbiting its star every 10 days. Because Ross 128 is so dim, the planet can be close and still be in the habitable zone, where liquid water could exist. What makes this system special is that Ross 128 is a quiet red dwarf, with far less flare activity than most. That means its planet is a more stable, potentially safer environment for life. Ross 128b is one of the best candidates for a habitable exoplanet. Imagine standing on its surface, a sky in permanent twilight, a large, reddish sun, and, perhaps, a world of extremes, one side in endless day, the other in night. The most interesting region might be the twilight zone between. Ross 128b is a prime target for future telescopes. It's one of our closest, most intriguing neighbors. The search for life could start right here, and it's only 11 light-years away. Next, we travel to Luyten's star, about 12.4 light-years away, a red dwarf with at least 2 confirmed planets. Both are super-Earths, larger than Earth, smaller than Neptune. Luyten b, about 2.9 times Earth's mass, orbits in the habitable zone with a year just 18.6 days long. If it has an atmosphere, its surface could be comfortable for life. Luyten c, about 1.2 times Earth's mass, orbits farther out and is likely a frozen world. The diversity in this system helps us understand how planets form around red dwarfs. Luyten b is one of the closest potentially habitable planets. What's a super-Earth like? Stronger gravity, maybe a thicker atmosphere. Questions we're getting closer to answering. Telescopes like James Webb are designed to analyze these worlds' atmospheres for signs of life. Luyten's star is a top target for investigation. The search for another Earth continues. Now, let's visit Altair, 17 light-years away, the brightest star in Aquila and a corner of the Summer Triangle. Altair is an A-type star, bigger, hotter, and whiter than our Sun, spinning incredibly fast. While our Sun rotates in about 25 days, Altair spins in less than 9 hours. This rapid spin flattens the star at its poles and bulges it at the equator, making it an oblate spheroid. The poles are hotter and brighter than the equator, a phenomenon called gravity darkening. Altair is a dynamic, powerful object, fascinating for astronomers. So far, no planets have been confirmed around Altair. Its youth and rapid rotation may make planet formation difficult, but the search isn't over. If planets exist here, they'd face intense radiation and stellar winds. Finding a planet around Altair would reveal how planetary systems form in extreme environments. Altair shows us the diversity of stars in our neighborhood. Even the brightest stars hold mysteries. Next, we visit Fomalhaut, 25 light-years away in Piscis Austrinus, a bright, young A-type star in a triple system. Fomalhaut A is surrounded by a huge dusty ring of debris, a protoplanetary disk much more massive than our Kuiper belt. The ring's sharp inner edge suggests an unseen planet is carving out a gap. For years, astronomers thought they'd imaged a planet, Fomalhaut B, but later found it was likely a cloud of debris from a colossal collision. We may have witnessed the aftermath of a giant cosmic smash-up. This system shows us planet formation in action, chaotic, violent, and ongoing. Fomalhaut's dusty ring is a snapshot of what our solar system looked like billions of years ago. Studying it helps us understand our own origins. Solar systems are forged in fire and collision. Fomalhaut is a reminder that creation and destruction go hand in hand in the cosmos. The drama of planet formation is unfolding right before our eyes. And it's happening just 25 light-years away. For our final visit, we travel 37 light-years to Arcturus, the 4th brightest star in the night sky. Arcturus is a red giant, an old star that's used up its core hydrogen and swelled to 25 times the Sun's diameter. If placed where our Sun is, it would reach almost to Mercury's orbit. Its orange color comes from its cooler surface, but it radiates 170 times more energy than the Sun. Arcturus is part of the Arcturus stream, possibly the remnant of a dwarf galaxy merged with the Milky Way. Any close-in planets it once had are likely gone, engulfed as the star expanded. There's some evidence of a distant super-Jupiter, a survivor of the star's transformation. Looking at Arcturus is like seeing our Sun's future, a glimpse into the fate of stars like ours. It reminds us that nothing in the universe is permanent. Stars are born, live, and die, part of a grand cosmic cycle. Arcturus is a celestial elder, connecting us to the story of stellar evolution. Its light is a lesson in time, change, and the life of stars. We've toured our cosmic backyard, visiting just a handful of the thousands of stars near our solar system. We've seen quiet red dwarfs with Earth-sized planets, super-Earths, spinning giants, dusty rings, and ancient red giants. Each stop reveals a new wonder, a different piece of the cosmic puzzle. Our neighborhood is rich, diverse, and dynamic, filled with countless worlds and possibilities. We're just beginning to understand the variety of planets and star systems that exist. Every discovery adds to our knowledge and deepens the mystery. We are the generation mapping our local galaxy, searching for signs of life. The spirit of exploration belongs to everyone, fueled by curiosity. Next time you look up, see the stars as destinations, as neighbors, Imagine the hidden worlds orbiting them, some frozen, some fiery, some maybe just right. The universe has revealed many secrets, but the greatest mysteries are still out there. Keep looking up. Keep asking questions. The adventure is just beginning.